If I take f of x as 0 here, then here I'll get it as a minus 3. So when I join these two lines, we will get a straight line here. So this is the equation which represents a straight line. TVC your variable cost, because as x changes, value of ax changes, so it is variable, and here b is fixed constant, that is why it is called as total fixed constant here. So linear revenue function can be graphically represented in this form. It is also a straight line here, so it is a selling price into number of units. It's the product of P into X. Hello everyone, a warm welcome to one and all. This is Yashruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. Today in this session, we are going to take up the new chapter, that is the linear function. So in this chapter, let us see the weightage of marks. So here in this chapter, you will be getting 1 marks for an MCQ and 1 3-mark question. So overall, 2 questions for 4-mark question. Now let us see what do you mean by a linear function. So any function of the form ax plus b. So a polynomial in the form of ax plus b is called as linear polynomial, and if this linear polynomial is written in the form of a function, then it is called as a linear function. And definitely here the degree of the variable must be equal to 1 and a and b are constant, where a cannot be equal to 0. So since if a becomes 0, the variable or the coefficient, since it is 0, then it does not satisfy the condition of linear function. So therefore, it has to be in the form of ax plus b, where a is not equal to 0. And the another condition why it is called as a linear function, because when you plot a graph for any linear function, you will always get a straight line. So that's why the graph of a linear function is always a straight line, where if you consider this ax plus b as a straight line, then here a is called the slope of the line and b is called the intercept. In other terms, it is also called as the y-intercept. So let us take an example here. So here, consider the function f of x is equal to 2x minus 3. So here, I have taken 2 points here. F of x is equal to 2x minus 3. Now here you can clearly see, if I take x is equal to 0 here, if I put x is equal to 0 here, then here so we will get the point 0 comma minus 3 and 3 by 2 comma as a 2 intersection point. So here x is equal to 3 by 2 is the point 3 by 2 comma 0, and if I take f of x as 0 here, then here I'll get it as a minus 3. So when I join these two lines, we will get a straight line here. So this is the equation which represents a straight line, and hence all the linear functions are called as linear function. And here the linear function is considered to study the linear cost, revenue and profit function. So why we call it as a linear cost, revenue and profit function? Again, the cost function, revenue function, profit function all represents a straight line in a graph. That's why we call them as a linear cost function, linear revenue function and linear profit function. Now let us study them one by one. What is this linear cost function? It is also called as total cost, denoted by C of x. So here x denotes the quantity or the number of units or output or a commodity or a product. So here C of x denotes the cost function, where x indicates the number of units produced. And the C of x also considered to be a sum of total variable cost as well as total fixed cost. So C of x can be written as TVC plus TFC here. Here TVC your variable cost, because as x changes, value of ax changes, so it is variable, and here b is fixed constant, that is why it is called as total fixed constant here. So now let us see what is TVC and TFC. So total fixed cost, it is defined as the cost which does not vary with the output. For example, here b, whatever the variable x can take, b will never change. It is constant. So such functions are called as total fixed cost here, and it is the cost a firm or a company has to bear even when the output x is 0. So even though when the production is 0, a company has to bear the common constant value here. For example, rent, insurance and other initial capital. So these are the example for your total fixed cost. So it can be represented graphically by a line parallel to the x-axis. Its slope is always 0 because total fixed cost is nothing but only the constant value. So always when you plot a graph of total fixed cost, you will always get a parallel line, any one line which is parallel to x-axis, and hence the slope of your fixed cost will be equal to 0. Next one is total variable cost. It is defined as the cost which varies with the output x, because total variable cost is AX in your cost function, and as x changes, TVC changes. So therefore, as x increases, it increases, as x decreases, it decreases. Thus, it is a variable cost. Now, as the production increases, they increases, and if the production decreases, they decreases proportionately. And here example is labor cost, transport cost of a fuel and operating cost. So clearly these are examples where obviously the production in a company increases, obviously the labor cost, transport cost of a fuel will increase, and if the production decreases, so vice versa, the labor cost also decreases. So these are all example for your variable cost. And when we draw a variable cost in a graph, then it will be a straight line passing through the origin. That is, if we plot, it is exactly passing through the origin, a straight line passing through the origin here. Thus, total variable cost is nothing but AX. So now here I have taken an example of your cost function versus outputs here. So here, by observing this graph, we can conclude that the total cost is always total fixed plus total variable cost, and hence we will write C of x is equal to TFC plus TVC. So here a parallel line to x-axis represents the total fixed cost, and here the variable cost increases as x increases, and hence the total cost is a sum of these two where it passes through this. So this represents your cost function C of x. This is your total variable cost, and this is the line which represents total fixed cost. And the next we are talking about the revenue function. So what do you mean by this revenue function? It is defined as the relation between total revenue and the output denoted by R of x is equal to AX plus B. So always revenue cost is nothing but the total revenue which paid for a number of units, and hence it is also a linear function which is given by AX plus B here. So total revenue is always can be represented as selling price per unit into number of units sold. So therefore the total revenue is P into X, where P represents selling price per unit and X represents the number of units sold. So linear revenue function can be graphically represented in this form. It is also a straight line here. So it is a selling price into number of units. It's the product of P into X. Next we have a linear profit function. So it is given by P of X, and it is defined as the difference between the revenue function and the total cost function. So it is always given by P of X is equal to R of X minus C of X. So since it is a profit, we can clearly say that the revenue value will be greater than the cost value. So therefore it is always given by R of X minus C of X. The next concept is break-even analysis. So what is this break-even analysis? Break-even analysis is a very important technique used to trace and establish the relationship between the cost production and sales value while exhibiting the probable profit. Hence, this analysis is also known as the cost volume profit analysis, also called as CVP analysis. So clearly by the definition, we can analyze this break-even analysis or CVP analysis is used to trace the relationship between the cost production as well as the sales volume whenever we are thinking about the profit. The next term is BEP, which is called as break-even point. So what is this point? This point will be represented in graph, and this point indicates the intersection of total cost as well as the total revenue function. So we know that the total cost and revenue function in the graph is represented. So this is your total cost function and this is your total revenue function. So the intersection of these two lines, wherever it meets, it is called as break-even point. So what is the necessary of this break-even point? So here, let us see. At BEP, the manufacturer does not make any profit or loss. So the intersection of both point always indicates the graph where the manufacturer incur no profit, no loss. It is also defined as the volume of the production in which the total revenue is equal to the total cost. So at BEP, your revenue function and cost function at any point, let me take point x1, at any point they will be same. So here I have taken an example graphically. So this is a straight line which represents the revenue function r of x. So this is your r of x and this is your c of x. So the dotted line here indicates the fixed cost here. So clearly this is your fixed cost and this area represents the variable cost. I already told you the point of intersection where both the lines revenue as well as the cost function meet is called as break-even point. So what does this point indicates? So if you look at the graph here at the break-even point, so we can take a point on the x-axis here. So let me consider x1. At this point, your revenue function as well as the cost function are equal, which means the company will incur no loss or no profit. So if you take below this point, then obviously the company will incur loss. So the area below this region represents the loss, and here after the point x1, if you observe the graph, or the area under this region denotes the profit area. So this is the point where we can decide whether the company will incur loss or profit. Now let us take the problems related to the total cost as well as total revenue function. First one, a publishing house finds the production cost directly attributed to each book is 30 and the fixed cost is 15,000. If each book can be sold for 45, then find cost function and revenue function. We know that cost function is given by total variable cost plus total fixed cost. So therefore here, from the first statement, the production cost is directly attributed to each book is 30. So we don't know how many books are there. Let us take it as x. So 30 into x will be the variable cost and the fixed cost is 15,000. So this gives you the cost function. Next is each book is sold for 45. That means the revenue is 45. Again, we don't know how many number of books are there. We have considered them as x. So therefore, revenue function is always selling price per unit into the cost. So selling price per unit is 45 and number of units is x. So therefore, the revenue function is 45x. Next one, the daily cost production C for unit of a manufactured product is given by C of x is equal to 3.5x plus 12,000. If the total cost production is 82,000, find the number of units produced. So the cost function is given and the total cost production is given. We need to find out how many units have been produced. So here C of x is equal to 3.5x plus 12,000. So here the total cost production is given, that is 82,000, 3.5x plus 12,000. So 3.5x is equal to 70,000. X is equal to 70,000 divided by 3.5. So x is equal to 20,000 units. Next question. The selling price of a product is 16 per unit. The variable cost is 8 per unit. The fixed costs are 10,000. Find the break-even quantity. So we need to find out BEP. So we know that at BEP, revenue function is equal to the cost function. So here, the selling price per unit is given 16. So let the number of units be x. Then the revenue function will be equal to 16x. Variable cost is given, that is 8. So for the number of units, it is 8x, and the fixed cost they have given us 10,000. So therefore, variable cost plus fixed cost will give you the cost function. Now here we have 8x is equal to 10,000. X is equal to 10,000 divided by 8. So therefore, x is equal to 1215 units. So therefore, at BEP, 1215 units are produced. Next question. A manufacturer sells his product at 8.35 per unit. He is able to sell his entire production. His fixed cost is 2,116 and his variable cost is 7.20 in rupees. Find the level of production at which he can make a profit of 4,600, the level of output at which he can incur a loss of 1,150, and the break-even level of production. So, if he wants to incur a profit, then we know that the profit function is always given by R of x minus C of x. So, from the question given, a manufacturer is selling his product as 8.35 per unit, which is a revenue. So, we don't know how many units are there. Let us take it as x. So, therefore, R of x will be equal to 8.35x. Also, they have given the variable cost as well as fixed cost. From that, we can recognize the total cost function. So, which is 7.2x plus 2116. Now, here P of x, because we are talking about the profit here. So, when profit is more than revenue, it minus C of x. So, therefore, now it is 8.35x minus 7.2x plus 2116. So, P of x. So, 8.35x minus 7.2x minus 2116. Now, the value of the profit is given, that is 4,600. So, this is equal to 1.15x minus 2116. So, 1.15x is equal to 6716. So, when you divide 6716 divided by 1.15, the value is 5840 units. So, if the production is or the number of units produced is 5,840, then the manufacturer can incur a profit of 4,600. The next question is the level of output at which he will incur a loss of 1,115. So, when there is a loss, obviously the cost production should be more than the revenue function. So, therefore, it is given by C of x minus R of x is equal to 1150. So, because it's a loss. Now, C of x is 7.2x plus 2116 minus R of x is 8.35x is equal to 1150. So, solving this, we'll get 1.15x is equal to 966. So, x is equal to 966 divided by 1.15, which is equal to 240 units. The next question is the break-even level of production. So, let us calculate the minimum number of units to be produced. So, that is third one. So, here R of x is equal to C of x. 8.35x is equal to 7.2x plus 2116. So, when we subtract this again 1.15x is equal to 2116. X is equal to 2116 by 1.15. X is equal to 1840 units. So, clearly you can observe this is at BEP. So, what does the point BEP represents? BEP represents the number of output to be produced or the minimum number of outputs to be produced where the manufacturer or the company will incur no loss or no profit. So, no gain, no loss. So, therefore, the minimum number of output should be produced is 1840. But here in the second observation, you can see it is 840 units. Obviously, they'll incur a loss of 1150. And in the first problem, you can see the output is 5,840, which is greater than the 1,840. So obviously they'll incur a profit. Thus BEP decides the minimum number of outputs to be produced. So more than that, it's a profit, and less than that, it is obviously loss. Next one, the daily cost of production C for X unit of an assembly is given by N. C of X is equal to 17.5 X plus 7,000. If each unit is sold for 30, then determine the minimum of unit that should be produced and sold to ensure no loss. Next is, if the selling price is reduced by 3 per unit, then what would be the BEP? If it is known that 500 units can be sold daily, what price per unit should be charged to guarantee no loss? Now the cost function is given here. So revenue function is varying here. So for the first one, they have given each unit is sold for 30. So let us keep the number of units as X. So therefore the revenue function will be equal to 30X. So then we need to determine the minimum number of output. That means we need to calculate how many units should be produced. So the minimum number of output is nothing but it is at break-even point where your revenue function is equal to the cost function. So therefore 30X is equal to 17.5X plus 7,000. Subtracting this, we'll get 12.5X is equal to 7,000. So X is equal to 560. So this is the number of units to be produced where revenue function is 30X. Next question they have asked, if the selling price is reduced by 3, that means we need to reduce the revenue function by 3. So therefore here R of X will become 27X now. Then again we need to calculate the BEP. So therefore here at BEP, when revenue function is 27X, R of X is equal to C of X. 27X is equal to 17.5X plus 7,000. So 9.5X is equal to 7,000. X is equal to 7,000 divided by 9.5. So this is equal to 736.84. Since we are calculating the number of units, we will approximate it to 737 units. So this is the minimum number of outputs to be produced. And the next question here is, if it is known that 500 unit can be sold daily, what price per unit should be charged guarantee no loss? So no loss means first let us find the revenue function. So cost function is given here. That is C of X is equal to 17.5X plus 7,000. So number of units sold is given, that is 500. So therefore here 17.5 into 500 plus 7,000. So that is equal to 15,750. So this is cost function. So if company should occur no loss means then revenue function should also be equal to 15,750. And revenue function is always selling price into number of quantity, which is 1,750. So now they have asked us to calculate the price per unit. So therefore, here price per unit is equal to 15750 divided by X is given, which is 500. This is equal to 31.5 per unit. So that means a unit should be sold at rupees 31.5 per unit so that it incurs no loss. Next one, a shoe manufacturer is planning production of a new varieties of shoe. For the first year, the fixed cost of setting up the new production line are 1.25 lakh. Variable cost for producing each pair of shoes are 35. The sales department project that 1,500 pair can be sold in the first year at the rate of 1,060 per pair. Find the cost function, revenue function, profit function, and if 1,500 pairs are actually sold, then what profit or loss does company incur? Also determine the BEP. So first let us find the cost, revenue and profit function. So cost function we can clearly see the fixed cost is 1.25 lakh and variable cost is 35 per pair of shoes. So therefore, C of x is equal to 35x plus lakh 1.25 lakh. And then R of x, so they have clearly said that so each pair of shoe can be sold at 160 per pair. So selling price is 160, number of pairs I don't know, so let it keep it as x. So the revenue function is 160x. Now find the profit function for the production sale. We know that the profit function is given by R of x minus C of x. So which is 160 minus 35, which is equal to 125x minus 1,25,000. So this is our profit function. Next they have said, if 1,500 pairs are actually sold, then what profit or loss does the company incur? So we need to substitute the value as 500 here. So therefore, P of x is equal to, fourth one, 125 into 1,500 minus 1,25,000. So that is equal to 1,87,500 minus 1,25,000. So this is equal to 62,500. So therefore, there should be a pair of 62,500. So therefore, the profit with no loss the company would gain is rupees 62,500 when 1,500 pairs of shoes are sold. The next is we are supposed to find BEP. So that is the break even point where the shoe manufacturer will incur no loss or no profit, which is nothing but revenue function is equal to cost function. So revenue function is 160x, cost function is 35x plus 1,25,000. So which is equal to 125x is equal to 1,25,000. X is equal to 1,000. So therefore, 1,000 pairs of shoes should be produced where the shoe manufacturer will incur no loss, no profit. So thus in today's session, we have discussed about the application of linear function while finding the cost and revenue function. We also analyzed the break-even point analysis. I'll meet you in the next session with the new concept. Until then, keep watching, keep learning and keep exploring. Thank you.